So in this video, we're going to go over how to come up with an equation of a real life situation. So you kind of know what you're going to be wanting to do for your actual summative. So once you've looked at the video of the bouncing ball, the first thing I want to do is figure out what my variables are. And for this video, it's going to be height and time. Once I get it set up, then I want to think about what's the general graph. So I like to call this a rough graph. Which is like in English how you have a rough draft, only this is just a general sketch of what I think it's going to look like. So in the very beginning of the video, it starts off with a ball rolling across the seat cushion of a small bench of some sort. And as it rolls across that, the height isn't changing, even though time is continuing on. So that's going to look like a straight line. Then, after a certain amount of time, it's going to fall off the bench and it's going to hit the floor. So I'm just going to draw it falling down. Remember, anything that is falling has to follow a quadratic. So I kind of try to make that curved. It shouldn't be a straight line. Then once it hits the floor, it's going to bounce, I think it's 5 times. 1, 2, 3, 4, 5, yeah. It's going to bounce 5 times. And each time it bounces, if you look at it, it doesn't quite go up as high as it did before. So I'm going to just draw what that would look like. So it's going to come down, it's going to come up, it almost reaches the same height, and then it's going to come up. It's not going to quite reach it, so that would be 2, here would be 3, here would be 4. Oops. Let me fix that. 4, 5. 1, 2, 3, 4, 5. And then it actually comes up and it starts to, right before it gets off the video screen. Now, from here we want to figure out what are the important parts of my graph. Now, the instructions that I gave you in the actual classroom said to only graph up to the second bounce. So the only thing that I need to, this would be what the whole picture would look like, but for creating the actual equation, I only need, here would be my first bounce, so I only need up to here. It's the only thing that I have to graph. So I'm just going to erase this other part really quickly. Okay. So now we need to think about what values are important. This is a straight line here. So we know that straight lines can be just modeled by y is equal to a constant. So when I look at this, we need to figure out what that constant is. So when I look at the bench, it looks like that bench, a good estimate would be about 30 centimeters. It doesn't look very high off the floor, so I'm just estimating it at 30 centimeters. Now, once I make this estimation, every other estimation that I make has to make mathematical sense with that estimation. So I can't just start guessing every point. There has to be logic and reason behind it. Okay, so now I know that this first part here is going to be y is equal to 30, because it's going to stay constant. And now I need to model the ball falling. So I'm going to model this part right here, which we know that anytime an object falls, that it can be modeled by a quadratic equation. So I need to figure out what quadratic equation is going to model that. Well, if it's falling right here at the top, then this must be the vertex of that formula. So I know that I'm going to be using the vertex form of the equation in order to solve that. So for here, I'm going to use the equation f of x is equal to ax minus h squared plus k. So this means that one of the points that I have to find is going to be this vertex here, so that we can plug it in. Now the second equation that I have here, well, this one's a little bit easier to see. This one also is going to be a quadratic equation. So just like I did for the blue, I'm going to also need the vertex here. Okay, now I've got to find my actual point. So the first thing I've got to do, for each of the bounces, I need to find the height, and I need to find the time at which, the height of the bounce, the time at which it reaches that height, and then also the time that it hits the floor. So I'm going to need to find also these points here. Okay, so starting off, I'm going to just draw a picture of what the video kind of looked like. So here's my bench, and the ball came, and I'm just going to draw a couple of balls here. Ball came down here, came here. Yeah. Let's draw it a little bit over more here. Now this is once again just a general idea of this is what it's going to look like if I were to freeze frame each one. And I'm just going to do this so that I can show you. So when I am trying to make these calculations, it has to be proportional. It has to make sense. Now, I estimated this to be 30 centimeters. So I know that this height, whatever it is right here for the bench, the yellow thing is my bench, has to represent 30 centimeters. So I went off and I looked and I got a ruler, and I actually measured that to be 5 centimeters. So I know that the proportion or the scale factor is going to be for every 30 centimeters, that's going to be represented by 5 centimeters, or that's going to be a scale factor of 6 to 1. So I'm going to use this, and this 6 is going to be my reality, and the 1 is going to be my scaled drawing. Or I shouldn't say the drawing, I should say the movie that I watched. So, so this is going to be my scale, and I have to make all of my other calculations off that. So the next height that I want to find is going to be this point right here, the height of the first bounce, after the first bounce. So I went and I got a ruler again, and I measured this out right here. Let's use a different color. I measured this height right here, and I got, let's see here, what did I get? I got 4.5. So this was 4.5. So I know if my proportion is going to be 6 to 1, if I got 4.5 for my movie, and I want to figure out what this is going to be here. So I'm going to multiply 4.5, so times 4.5. So x is going to be, when I multiply that out, it will be 27. So I know that the height of this is going to be roughly about 27 centimeters. Okay. All right, now, so I'm just going to make a little coordinate really quick here. And we'll go here with the blue. So I know that this is going to be 27, and I know that this is going to be 30. Now I need to go back in the time, and it's just a matter of freezing the frames to figure out at what exact time those bounces take place. So when I did that, I got that the ball first falls at 1.1 seconds. The first time that the ball hit the ground, it happened at 1.23 seconds. And of course, when the ball's hitting the ground, the height is going to be 0. So I'm going to just put that coordinate in here. When it gets to the first height that it reaches after the first bounce, I got that happened at 2.02 seconds. Now, I could go and freeze the frame here as well, but knowing that parabolas are symmetric, if I take the difference between these 2 points, so this first one happened at 1.2, and the second one happened at 2.02. I'm sorry, it happened 1.23. If I subtract this to figure out how much time passed right here, I should find what this point is. And that's important because that helps us create a more realistic parabola, because if our timing is never going to be perfect, is stopping the videos unless we have things to measure it. So instead, we're going to go off of the fact that parabolas have to be symmetric. So this distance here has to be the exact same as this distance over here. So I'm just going to do some subtraction. And I'm going to get 0.79. And then I'm going to take that 0.79 and I'm going to add it to my time here. And I'm going to get 2.81 when I take this, and then I'm going to add it to that. So this should be 2.810. Should be my coordinate here. Okay, now that I have my coordinates, the next thing I need to do is to make an equation. So filling it into this formula here. There, created some space for me to work. Just gonna zoom out really quick. Just a little bit so that we can still see our points, but we can actually create our equations. So we're going to create a piecewise function with 3 different equations. Let's just point those out really quick. So we're going to have this equation here will be our first, which will be a straight line. Then we need to create this parabola here, and then we need to create the second parabola here to represent that. So I'm going to start off with this line we already said. So I'm going to start off with this parabola and how to solve for it. So starting off, keeping it with the color it's supposed to, I'm going to start off with, I'm going to change f of x to y because I'm going to end up solving for some points. So I'm just going to say y is equal to a times the quantity of x minus h squared plus k. That's just the general vertex formula. Next, I'm going to plug in my vertex. So I'm going to say y is equal to a times x minus 1.1 squared plus 30. Okay. All right. Next step, and this is why it's important that we have this point right here. I have the equation, except for I still have this variable a. The variable a has to be solved for. So remember, you cannot just look at quadratic functions and figure out what a is. A is not a slope. Quadratics don't have slopes. You have to solve for a. But because we have this point down here, we can plug this in. I'm just going to write this a little bigger. 1.230. This is an actual x and y value that I can plug into my equation. So here's my x value, here's my y value. So I'm going to plug it into my equation and then solve for a. So I have y is going to be equal to 0. Then I'll have x is going to be 1.23 minus 1.1 squared plus 30. Okay. That can be simplified to 0 is equal to a times, when I simplify this expression, I get times 0.0169 plus 30. Take the 30 over to the other side, I get negative 30 is equal to 0.0169a. Divide both sides. Now, I could plug this into my calculator and get a crazy long decimal, but that actually makes my answer less accurate. So what I'm going to just say is that a is going to be equal to negative 30 divided by 0.0169, and I'm just going to leave it like that completely. So I know that this first equation for this part right here is going to be, I'm just going to erase some of my work, it's going to be, I'm going to change it to f of x because it's going to go back to our function, is going to be negative 30 over 0.0169 times x minus 1.1 squared plus 30. Okay, so that's going to be that equation. Now, I'm going to do the exact same process for the second equation. Okay, and I'm just going to work out this equation really quick, and I'll show my steps, but it's going to save time if I just do it first and then explain. Okay, so here's how I did it. I started off with the vertex form, and I plugged into my vertex. Then I used one of the coordinates that I had, 1.230, and I plugged it in. So here's my 0 value for y and my 1.23 for x. After that, I simplified this, and I got 41. Brought the 27 over to the other side, divided both sides by this number here, and I got my A value. Once I got my A value, I plugged it back into the formula, and I was done. Okay, so, and the beautiful part is that if you wanted to, you could plug these two into Desmos, and it would create a perfect function that lines up right here at this point. Okay, so now putting together the piecewise function. This is the final step. I'm going to erase some of my work and just get the important parts together. Okay, so now I just moved my two functions over to each other. All right, so now we have these two functions, and remember that this function up here is just going to be a straight line. So this would be f of x is equal to 30. Okay, so we have these three equations, so I'm going to write my piecewise function in black. So I'm going to have the function f of x is going to be equal to, and I'm going to put these three all together. So the first one is going to be, the first line I'm going to have is when f of x is equal to 30. The second one I'm going to have is when f of x is equal to negative 30 over 0.0169 times x minus 1.1 squared plus 30. And then I'm going to have when f of x is equal to negative 27 over 0.6241 times the quantity x minus 2.02 squared plus 27. Next thing that I need to figure out is what are the domains. So the domain, for what x values is this function going to be true? I'm just going to set it up here really quick, just like this. All right, and to make it a little bit easier on the eyes, because these are going to blur together, I'm going to use the actual values in a different color, but that's just so that you can see them a little bit better. All right, so for 30, for f of x is equal to 30, this line right here, this is going to start when my x value is going to be, oh, it's trying to get me to do something here. When my x value is going to be 0, and it's going to end when my x value is 1.1. Now, my second value is going to pick up right where that left off, so it's going to be at 1.1, pardon me, and then it's going to stop right here when x is going to be 1.23. All right, and then my final function is going to pick up at 1.23 and then is going to drop off, or I'm sorry, not drop off, but stop at 2.81. And that would be it. That entire thing would be how I would solve this problem. There will be a little bit of a write-up, but there won't be a whole paragraph that you will have to do for your actual summative. And you will have the entire 90 minutes to take this. So I think that's just about it. So the process will be very, very similar. Make sure that you understand how I got each equation, and I think that you'll be fine.